Okay, welcome back, Algebra 2. Let's go ahead and now talk about rational exponents, okay? So when we write the nth root in exponential notation, okay, so what does that mean? That means that when we take the nth root, so the nth root of a, for example, and we write it as instead the a to the 1 over n power, okay? The 1 over n, so this is called a rational or sometimes fractional. Those are interchangeable. We can say either one of these. Okay, this is called a rational exponent, okay? So this 1 over n is a rational exponent, and that makes sense, right? Because rational numbers are usually the numbers we can express as fractions, or the ones that have terminating decimals, repeating decimals, etc. We they're rational numbers, so we can write them as fractions. Sorry, I lost my train of thought. So then 1 over n is a type of rational number, okay? But the issue is that 1 over n is too specific, right? Because not all fractions look like 1 over n. For example, 2/3, 7/5, right? So we need to be more general, okay? So now let's talk about a to the, and we don't always need parentheses, right? I can just have a to the m over n power. Let's talk about a to the m over n and see what we can do with stuff like that, okay? Right, because we just said m over n is more general. Let me go ahead and highlight rational fractional exponent, okay? So m over n is our rational exponent. How can we rewrite that? Maybe perhaps using radical notation. Well, let's kind of dissect it a little bit, okay? For example, let's talk about 2/3, the fraction 2/3. If you think about it, another way to write this is 1/3 times 2, right? Because when I do 1/3 times 2, it's just technically over 1, multiply across, I get 2/3, okay? This is convenient to us because what I can do is I can rewrite this a to the m over n. I keep the a, but what I'm going to do is I'm going to write as 1 over n times m. Oh, and there's an exponent property that says whenever I have multiplication of exponents, I can do it as a to the 1 over n raised to the power of m, right? Because this tells me, this right here says multiply the exponents, okay? And so now we know this right here, we're familiar with this because this is this, and we know that's the nth root of a. So then I write this as the nth root of a to the m power. And this is going to help us a lot in calculating this. Okay, so here's what you want to take away from this, okay? A to the m over n is equal to the nth root of a raised to the m power. Now, since multiplication is commutative, what I could have done is I could have switched these two exponents, right? So that means I would actually get a to the m nth root of a to the m. But you're going to find that when you do a to the m, that's a very gigantic number. And it's hard to take the nth root of a really big number, especially when you don't know how that number breaks down. However, when you do the nth root first, you break it down and then raise it to a power. And you know what that number is because then you can just, you can just multiply it out. If you can't do it by hand, pop it in the calculator. Okay, so this is what we want to take away. All right. And so if m is negative, then we would obviously keep simplifying. We'd want a positive exponent. We would just take the reciprocal. Okay, so if m is negative, we would get 1 over this right here. Let's try it. Okay, now something to keep in mind is that m, if m is 1, we don't need to do this because then we just get 1 over n, and we know how to deal with 1 over n. It's this right here. But if m is bigger than 1, then that's when we need to do all this stuff. Okay, let's do that stuff. So evaluate the following expressions without a calculator, okay? Whenever you do stuff like this, you guys try your best to do it as much as you can without the calculator. But eventually you're gonna see some problems need a calculator, and we'll see that in the next example. But let's start with this, 4 to the 5/2 power, okay? I wanna figure out what this equals, okay? So that's my goal. What is this equal to? Well, if I rewrite using the stuff we learned up here, then we would get, this is gonna be square root of 4, because my m is 5 and my n is 2. Okay, so it's going to be the square root, right? You wouldn't say the 2th root. You would say square root of 4 raised to the 5th power. Okay, so what does that equal to? Square root of 4 is 2. 2 to the 5th power, that's 32. So this guy is equal to 32. Awesome, not bad at all, right? Let's try one more example with this. And I forgot to make this exponent negative. Make that negative, okay? 81 to the negative 3/4 power. Okay, no big deal at all, right? Because when we have a negative exponent, we just take the reciprocal. So let's start with that. Okay, let's start by taking the reciprocal. So 1 over 81 to now the positive 3/4 power. Now we work with the 81 to the 3/4. Okay, 1 over, this is going to be our m is 3, our n is 4. So the 4th root of 81 to the 3rd power. Okay, what's the 4th root of 81? We found that earlier, that's 3. So 3 to the 3rd power. What's 3 to the 3rd power? 27. Okay, so this is equal to 1 over 27. Okay, hopefully you're seeing that this isn't actually too bad at all. Okay, now let's see some examples where we're going to need a calculator. Okay, so I'm not sure how many of you were able to get your hands on a TI 30X2S. So if in the case that you did, whenever you use a fractional exponent, you're going to type in your number. So let's start with this one. For those of you who did get the TI 30X2S or some other calculator that you might have, right? You're usually going to start with your base, so 4. Then to use the exponent, we're going to do caret. So you should be able to find a button that looks like an up arrow. It's called a caret. Then for the TI-30X2S, this is really important. You're going to open a parentheses, because if you just do 1 divided by 5, it's not going to recognize it. It's going to do 4 to the 1st power and then divide everything by 5. Okay, but we don't want that. We want 1/5 as our exponent. So raise 4 to the power of 1 divided by 5, right parentheses. So you need to wrap the 1 divided by 5 in parentheses. Okay, so do that in your calculator and see what you get, and then I'll show you how to do it in Desmos. All right, so do that really quick. Okay, hopefully what you get for this one is 1.319. We're going to round to 2 decimal places. So 1.32. Okay, so this is, and we'll use approximately, right? Because it's not the actual value, 1.32. Okay, so we're pretty much going to do the same thing for all 3 of these, right? So why don't we just go ahead and pop them into Desmos, just so we can see, especially if you don't have access to a calculator, right? I would say use the one on your phone, but usually that one's a little finicky. So let's go ahead and just use, let's see what Desmos has to offer, okay? Let's head over. Okay, so here is Desmos, right? Despite the fact that it says it's a graphing calculator, we can definitely use it as a normal calculator. So let's see how. Let's go ahead and pull up our keyboard. So we'll try the first one as well. So 4 to the 1/5 power. So 4, click on the, or press on the 4. Then we're gonna press on this A to the B button to get an exponent. Okay, and then we're gonna do 1 divided by 5. Okay, so 1 division 5, that gives you the fraction straight up. So 4 to the 1/5, and it tells you the result right here in this gray little box. So 1.32. Okay, just exactly what we got. So let's do the others, okay? The other 2 were, part B was -30. So we'll use parentheses, right? Because we want that -30 to be inside the exponent. So parentheses, -30, right parentheses. Then we'll do the A to the B button to get an exponent. 2 divided by 3. And there's our answer, 9.65. Okay, we'll round that to the second. So 9.65, make sure you take that down, because we'll be moving back to the notes screen in a little bit. in a few seconds actually. And then we have the 4th root of 10 to the 5th power. Okay, it's the 4th root of 10 to the 5th power. So how can we write that as an exponent? That'll be 10 to the 5/4. So 10 in parentheses. And then, and actually we don't need the parentheses, but we're already here, so might as well just keep going. To the 5/4. Okay, we needed the parentheses in this one because we need the negative 30 to be to the 2/3, not just the 30, the negative 30. So here we have 17.78 about. Okay, 17.78. Okay, let's move on back. Okay, so now let's go ahead and write down what we got. So we got 9.65 for B, right? Oh, I'm using the wrong one. Let me stop that. There we go. This was approximately 9.65, and this one was approximately 17.78. Okay, cool. So we got answers for all those. Now let's just finish our last part, solving. Okay, solve the following equations. And we're going to use our newfound knowledge. Okay, so for A, you kind of are used to this by now, right? If I want to solve for x, I need to try to get x by itself. Before I can do anything with the x cubed, I need to get rid of this 1/4. How do I do that? I multiply by its reciprocal on both sides. So times 4 times 4. We get x cubed is equal to 8. You can probably find out what x is just by looking at this, but let's practice with our nth roots, right? So I can do this one of two ways. I can actually use the root. So here, remember, since you're doing the 3rd root, the cube, we need the cube roots. So make sure you have a 3 here. And we'll do the same thing on this side. Remembering that since this is odd, I do not use plus minus, right? No plus minus, right? Since 3 is odd. So x is equal to the cube root of 8. Another way I could have done that equals 8. I could have raised both sides to the 1/3 power. I'm allowed to do that, raising both sides to the same power. Okay, if I do that, the 3 times the 1/3, those cancel each other out because 3 times 1/3 is 1. Then I'm left with x is equal to 8 to the 1/3 power. Okay, something dangerous about this is when you do, for example, like the 1/4 power, you have to recognize that that is an even root, so you'll need a plus minus in front. Okay, but we'll talk about that in this one. Okay, so either way, what are these equal to? What times itself 3 times is going to give us 8, 2. So x is equal to 2 is our answer. Okay, one more to send it home. Okay, we have x plus 5 to the 4th power equals 16. So we'll need to take the 4th root of both sides to get rid of that 4th power on the left. 4th root of 16. 4 is even, so I need a plus minus in front. So x plus 5 is equal to plus minus, what is the 4th root of 16? What times itself 4 times gives us 16? That's good old 2. And then we just subtract the 5. So x is equal to negative 5 plus or minus 2. Now we're able to do both. So x is, what's negative 5 plus 2? That's negative 3. What's negative 5 minus 2? That's a negative 7. Very cool. Okay. Hopefully that sounds okay, you guys. We're going to do some more practice with this in class on Thursday. All right. I will see you then. Have a great rest of your day. Okay. Bye-bye.